So today we're going to talk about limits. So what is limits? Limit is basically the word limit. Okay. So you can imagine what the word limit might mean. So so let's say we have this function. Let's say f of x equal to x cube x square minus one minus x. So I want to say I don't want to know what is. See, we never know the what is the value of when x is equal to one. We cannot put this value and calculate, right? Uh, because this 1 is not like if it will be dividing by 0. So what we want to know is that what is the value of f of x near 1. So we can approach, let's say let's say this is f of x, this is x, right? Let's say let me make a table. So we can take the value of 1.9, 2.1, then maybe 1.99, then 2.01, maybe like that. Some values will come, right? And then we try to plot it. So if we plot it, we see the value of f of x gets very. Oh, sorry, this was sorry. I messed up. Yeah, so let's say, sorry. Wait, let me just erase this. Erase 0.9, 1.1, 0.99, 0.2, sorry, 1.01. So these are the very closest values to 1. We see the f of x value converges to the value of 2. So this is what we informally call, this is called informally. I'm informally defining what limit basically is. Okay, so what limit basically is. So we kind of formally write this as limit x tends to 1 f of x. This is limit L. Okay. So let this be some formally, let's say it goes to C. So if we write this sum, we can write this formally x tends to 1 x square minus 1 by x minus 1 is equal to 2. So this is the formal definition. So formal definition, how you write this whole shit. Okay. So let's explore this. Okay. So and additionally there are two things called LHL and RHL, left hand limit, right hand limit. Okay. So if you are approaching from the left hand side, so means the values of 1.9, 1.99 and so on, this is called left hand limit. So limit x tends to, let's say in our case 1, and we represent this as a minus. Okay. So I'm not sure, let me just check which one was minus, which one was plus. Give me a second. I think so this was the minus one, no, if I'm not wrong. Yeah, this is the minus one, minus f of x. And if we approach from the left hand side, let's say 2.01, 2.000001, so this becomes limit, sorry, this will be 2. Limit x tends to 2 plus f of x. So basically this 2 plus means nothing but 2 plus means this is 2 plus an epsilon, where epsilon tends to 0, or 2 minus means 2 minus epsilon when epsilon tends to 0. Simple. No need to think much about it. So let's see if we have a constant function. Let's say f of x is, let's say, 2. So limit of, let's say, x tends to any constant 2 will always be 2 logically. So whatever the input is, it will converge to the value of 2, right? That's the thing. Oh, additionally, you have to realize something. This is called the LHL. This is the RHL. Okay. So we discuss something called, does it exist? Does the limit exist? Okay. The limit only exists at C if LHL is equal to RHL. So in our case, in the above case, the LHL value was coming out to be 1.99999 something. The RHL value was coming out to be 2.000001. So which is very close. So this LHL is equal to RHL. That's why we can call this to be correct. Right. So this was the limit in that case was existing. The limit existed. Okay. So let's get back to this. So it's your work to check out all the examples. I am not going to go through the examples. I'm just going to teach the basic stuff. Okay. So some rule exists here. Okay. So let's say we have limit f of x, this extends to c, limit extends to c, g of x. So if this is, let's say, L, this is M. So for f of x plus g of x, the limit can be summed up to be L plus M simply. For difference as well, this will be existing. For product also it will exist. So f of x, g of x can be broken down into L into M. The quotient rule will exist in some cases but will not if g of this g of x will never be not equal to 0, then you can separate it as L by M. If you have a constant, you can bring it out. Let's say you have k f of x, you can write it as kl. Okay, and the roots, the powers also come out. So let's say if you have f of x to the power n, this you can write as limit to the power n as well. So these things exist. So for example, let's say if I have limit x tends to 2 x cube plus 4x square minus 3. So using that rule, what will I do? I'll do limit x cube. I'm not writing the thing. So you don't have to write LIM every time. You can start writing this as LT. LT x cube plus LT 4x square minus LT 3. So now we can use the power rule. So we can write LTX cube plus 4 LTX square minus LT3. So constants are constant only. The limit x tends to 2, what is the value of x? It will be 2 only, right? So when x tends to x, what will be the value of x? So when x, basically when limit x tends to c, x, this will always be c. So we can put this as 4 into 2 square, and this will be 2 cube. So this will be what? This will be 16 plus 8 minus 3, that will be 21. So you solve this sum, very easy sum. And yeah, so logically from that you can always say, let's say if you have a px is equal to summation of ai x to the power I. This is a basic polynomial, right? So like the earlier one was a polynomial as well. So this one was a polynomial, right? So in this case, what you can easily write is something like this. Wait, why is this stuck? Yeah. So we can kind of make this lemma limit x tends to c, p of x is nothing but p of c. We put the value of c in this polynomial. What is the output is? That is this thing. Okay. So that is the thing. Sometimes you might also make the sum easier by eliminating the factors. So for example, if I do limit x tends to 1, x square minus x square plus x minus 2, we can synthesize this. The upper one is x minus 1 into x plus 2, the lower is x into x minus 1. So see here, if you put the value of 1, right, so it will become what? 1 square minus 1, and you get 0. So you cannot basically put the value there. If you put the value there, you get a 0 division, so you cannot put that. So if you remember the division rule, you can only do this division only if g of x is not equal to 0. So it's equal to 0. So what we do is that we factorize this, we cancel the x minus 1, we get x plus 2 by x. Now you can put the value of 1. So what will be the value of 1 be? 1, and 1 plus 2, the value will be 3 if I am not wrong. Let me check the answer. Yes, it's correct. Okay. Sometimes you have to do a bit of math as well. So for example, let's say if you have x square plus 100 minus 10 by x square. So limit x tends to 0. So in these cases, we do something called conjugate rationalization, if I am not wrong. I have studied this in school, I don't remember. So you do multiply with the conjugate. Okay. So the conjugate is nothing but the reverse of the upper one. So something like this, x square and the conjugate will be 100 plus 10, and this I'm not writing this plus 10 here, and when you multiply the top it will become x square plus 100 minus 100 by x cube minus root over x plus square plus 100 plus 10, right? This gets cancelled, this gets cancelled, so this becomes 1 by root over x square plus 100 plus 10. Now put the value of 0 here, you can put the value of 0 here now, so this becomes 1 by 10 plus 10, 1 by 20. Let me check the answer if this is correct. Yes, this is correct. Okay, so we have solved two sums and everything. Okay, now we will talk about something called the sandwich theorem. So it's not a sandwich, but yeah. So let's say you have three graphs. Okay, let's say this is one graph and this is another graph, and this is another graph. So let's name this as f of x, g of x, h of x. Okay, so if f of x is sandwiched between two functions, so here you can see it is sandwiched between, like let's say at this point it is sandwiched, right? So if in an open interval as well, so here it is for a very small interval there is, but in any interval there is, you can always say, okay, that the limit of g of x is equal to the limit of h of x equal to your limit. Okay, so if this is the case, okay, so if this happens, then limit c f of x is also equal to L. So means, if let's say in simple words, if both the breads of the sandwiches have the same limit, the filling will have also the same limit. This is the basic logic you should always understand. So let's try to solve one sum. You can be given a sum like this. Let's say you have to find all the functions u that are in the middle of this. Okay, so yeah, no, so this is given to you, sorry, this is given to you. Now find the limit of u. Okay, how do I find that? So if you see what is at let's say at 0, right, when it is equal to 0, limit tends to 0, sorry, tends to 0 for this, tends to 0 for this, the limit for this is 1. When it is tends to 0, limit for this is 1, then the limit of u will also be 1. So in the exam there might be a case this is not given to you. Okay, so yeah, so it can be some random like huge function it's given to you. You have to find the lower limit, you have to find the higher limit, and then whose limits are equal, then you can easily find out this, because finding the limit for this might be harder. So you have to kind of do that thing. Okay, now we talk about the precise definition. Whatever I told you, like informally I have defined limit and everything. So wait, I think my Hotstar is coming in the scene. I have to just close all of these, I guess. I'll close all of this, and yeah, let's say the precise definition of limit. This is from word to word from a book. Okay, so a limit of f of x as x approaches c is L, and limit x tends to c f of x is equal to L if and only if for all numbers epsilon greater than 0 there exists some delta greater than 0 such that f of x minus L is less than unity whenever 0 less than x minus c less than delta. Simple bath, like very simple thing. This means when tends to c, L will tends to f of x. As simple as that. This is the main logic behind this. Nothing that is very complex. Okay. Okay. This is like the simple logic that we have given. So this is like the formal definition. If somebody asks what limit is, you have to give this definition. So in your college exams, I guess you have to write this definition. But the simple logic is this: when x tends to c, L will tend to f of x. There are many sums you can do this, and yeah, the LHL and the RHL is something we have done, but still let's do one LHL sum. Let's say limit x tends to 0 plus root x equal to 0. Prove this. Okay, so now let's say c is here 0, L is also 0, right? So we need to find some delta such that mod root x minus 0 is less than epsilon whenever 0 less than x equal to delta, or root x less than epsilon. Okay, so if you square this, you can get x less than epsilon square. Take delta equal to epsilon. Okay, if delta is equal to epsilon, so x less than epsilon square or something like this, then root x will be epsilon whenever this case will happen, logically, because epsilon is less than epsilon square. I think so, no? But epsilon is a very small value, no? Epsilon square will be less than epsilon. Sorry. So we can say this, sorry. So like this you can prove it. Like this is a very formal proof. You will not be asked this anywhere. So yeah, there are fun geometrical proofs like limit. You have to remember these. Limit 0 sine x by x. Okay, so this is 1. So I'm not doing the huge as proof. These can be proved by geometrically as well and everything. Okay, so you have to remember this. This is very important. So like for example, you might be given something like this. Let's say limit 2 sine 2x by 5x. Okay, x tends to 0. How do you solve this? So you just do what? Sine 2x by 2x into 2 by 5. No. Into 5 by 2. Right. So this thing will be 1. So this answer comes out to be 2 by 5. As simple as that. It's very easy sums. Okay. So yeah. I do have like a list. I have to find that. Where do I have the list? Give me a second. I have to find the list of the limit formulas. So that you can just note this down, then you can solve a lot of sum. Limit formulas. Give me a second. Yeah. So one is limit x tends to 0. All are x tends to 0. Sin x by x is 1. Tan x by x is equal to 1. 1 minus cos x by x is 1. Is 0. Sorry, is 0. And the inverses are also 1. Okay, by the way, the inverses are also 1. One more interesting thing that is required a lot is 1 minus cos x by x square. I think this was the formula. I don't remember right now. It's half. You can remember this. These kind of things helps a lot in exams. So another thing is ln 1 plus x by x is also 1. Ln 1 plus x by x is 1, or 1 plus x to the power 1 by x. See, you have to solve these sums. Like this is something I cannot make you practice. Is e, for example, and I don't think there are more important stuff. There are many sums you can find. I'm just teaching you the formulas. Like you have to apply it. Like let me see if I get good sums. I can do that then. Wait, give me one good sum. Let me take a gate PYQ. No, that's better. No, if I'm not wrong. Give me a second, give me a second. Uh, where is a limit sum? I need a limit sum. They're giving me calculus sums. This is, where is a limit sum? Yeah, this is a gate p by q, for example. Let's solve this. Mm, limit x tends to, you have to tell me what is the formula we're going to use. I have taught you this. So, so the first thing you know that we cannot put minus 3 here. So the best approach is do the conjugate thing, right? X plus 3 into root over 2x plus 22 plus 4, and here it will be what, 2x, I'm doing jumps, okay, 16, right? So x plus 3 into whatever this thing is, into 2x plus what is this, 2x plus 6, right? So can you still put it? No, you cannot still put it. So we can divide by x above, and so 2 plus 6 by x by 1 plus 3 by x into root of 2x plus 22 plus 4. This is something you can do, right? So 2 minus 2 by 1 plus minus 1. So this is becoming 0 by 0, right? So you cannot do this. So we now have to use something that I have not taught you yet. It's called L'Hopital rule. I don't know. Is it a hospital? I don't know. So L'Hopital rule says simply if you have 0 by 0. Yes. Okay. Let me get the exact statement. I think that would be better, right? L'Hopital rule, exact statement. Yeah. So if it is 0 by 0 or infinity by infinity, so you have to derivate the top and bottom. So let's say we have x square by x, right? Okay. So this, let's say x tends to 0, right? You cannot solve this, right? So you can do x and then it becomes 0, right? But let's say we don't have that rule. So what, here also you can see it is a 0 by 0 case. We can derivate up and bottom. So let's derivate this. Derivation will become what? 2x by 1 or equal to 2x. Now you can put, it's what? It's not 0 by 0 case, right? Put the value of 0, comes out to be 0. So that is how you can do it here as well. So usually in an exam, if you get 0 by 0 case, please don't do this bullshit I was doing right now. Please do it completely using L'Hopital rule. So for example, let me erase this. Can't I get a bigger eraser? I think I can select, no? And then delete. Yeah, I can select and delete. Okay. So yeah, so L'Hopital's rule. So here you can see it is x 0 by 0. So put the value of minus 3 here. In the earlier case also we were getting 0 by 0 only, na? So minus 3 would be 16, 0 by 0 case. Okay. So we will put derivation. So minus 4, so you have to derivate this. So this will become what? Minus 1 by 2 by root over 2x plus 22 into 2. Okay. Denominator will just be 1, right? So now you can just put the value here. So it will be into 1 by 4 into 2. So the answer is 0.25. So simple. This thing was 2 marks in GATE. I'm not even kidding. This is such a simple sum, right? So if you notice, this was a very simple sum. Let's do one more limit sum. I guess that would be more refreshing. So for example, let's say I have limit. So most of your sums can be solved by L'Hopital, by the way. Okay, so it's not something that is cannot be solved by L'Hopital. So this is also 0 by 0, no? Yeah, so this is also 0 by 0, 0 by 0 case. Okay. Again, L'Hopital rule, blindly. 1 by root over x by 2 by e to the power root 2x into 2 by 2 root x. Yeah, this 2 gets cancelled. So this will be, I guess, minus. Yeah, there will be one minus e to the power 2x by x. This gives you what, 1 by root over 2x by root x by e to the power minus 2 root x. This gets cancelled, half. So 1 minus half into 1 by e to the power 2 root x. Now put the value of x here has to be 0, then this becomes what, 1, right? So the answer is minus 0.5. Let me check if this is the answer. Yeah, this is the answer. So again, a 2 marks question in GATE. I'm not even kidding. This is how easy the sum is. Let me check last one more question. If I get some good question, I'll tell it. If I don't get one, we will end this here, I guess. Like, okay, this question, this is actually a 2 marks question in GATE. Sine x minus 4 by x minus 4 limit x tends to 4. So this is what, 0 by 0 again, but this we had learned sin x by x is 1, so this is just 1. Let me check the answer. Yeah, this is very like trivial, right? This is very obvious. One last limit, let's try to do it. So let's say limit x to the power 4 minus 81 by 2x square minus 5x plus minus 3x tends to 3. Is this 0 by 0? 81 by, yeah, the upper one is 0. Next is what? Minus 50 minus 3 plus 8. Yeah, it's 0 by 0. Okay. So we L'Hopital. Again, blind L'Hopital by 4x minus 5. Now is it 0? No, this is 20 by why am I writing 20? 12 minus 5, 4 into 27, right? So this is what, 108 by 7. Let me check if this is the answer. This is the answer. We solved like what? This is a 1 mark questions. We solved like 5 mark question with the knowledge we already have, right? So yeah, that's it for limit. You don't need more than that, and you can get good marks if you do this only.